Hello all. So in today's class, let us look at the equation of pole and polar using polar coordinates. Now consider a conic. Suppose you have a conic and consider a point. So let us denote it by r1 theta 1. So we'll have lines from so we can draw chords from the point r1 theta 1 to the conic. So there will be point of contact. So at the point of contact we can draw the tangents at the point of contact. So the tangents will be intersecting at the points. So the locus of such points are called as the polar of with respect to the point r1 theta 1, and the point r1 theta 1 is called the pole of the conic. So that's how we define the pole and polar. So we have a point r1 theta 1. So from there we have different chords. So you have the tangents at the extremities of the chords. So the tangents will be intersecting at those points. Now the locus of those points are called as the polar. Now here we'll start with the equation of the conic in the polar form, and we have already seen the equation of the chord of contact, and using that we'll find out the equation for the polar with respect to the point r1 theta 1. So let us look at the equation of polar of the pole r1 theta 1. So for this, let us consider the conic L by R equal to 1 minus E cos theta and conic in the equation, and R1 theta 1 is the pole here. Now from the pole we'll be we'll be drawing chords. Now let me take the vectorial angles at the ends of the chords to be alpha minus beta and alpha plus beta. So we have already seen if the vectorial angles are alpha minus beta and alpha plus beta, then we have seen the expression for the chord of contact with these vectorial angles. അപ്പോൾ chordന്റെ equation എന്ന് പറയുന്ന L by R equal to minus E cos theta in plus sec beta into cos theta minus alpha. Now as we know, this chord will be passing through the point r1 theta 1. So therefore the equation of the chord uh, will be satisfied at this point. അപ്പോൾ r-ന് പകരം r1 ഉം തീറ്റയ്ക്ക് പകരം theta 1 ഉം സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക. So we'll get L by r1 equal to minus E cos theta 1 plus sec beta into cos theta 1 minus alpha varum. So let us call this as equation 1. So we have got the equation of the chord of contact, and now let us consider the equation of the tangents at the extremities of the chord of contact. The equation of the tangents where the vectorial angles are alpha minus beta and alpha plus beta. അപ്പോൾ ടാൻജൻസിൻ്റെ ഇക്വേഷൻ എന്ന് പറയുന്നത് L by R equal to minus E cos theta plus cos theta minus alpha plus beta വരും, and L by R equal to minus E cos theta plus cos theta minus alpha minus beta വരും. Now from these two equations, the these two values are same. L by R ആണ് ഇവിടെ minus E cos theta ആണ്. So L by R plus E cos theta will be equal to cos theta minus alpha plus beta, and that is again equal to cos theta minus alpha minus beta. Now we have the equation of the tangents. So let the tangents meet at the point rho phi. So tangents in the point of intersection rho phi ആയിട്ട് എടുക്കുക. Now if the point of intersection is rho phi, അപ്പോൾ ഈ രണ്ട് ഇക്വേഷനും that will hold when r is equal to rho and theta is equal to phi. So from there we'll get L by rho equal to minus e cos phi plus cos theta ക്ക് പകരം phi വരും. അപ്പോൾ cos phi minus alpha plus beta and L by rho will be equal to minus e cos phi plus cos phi minus alpha minus beta. Now again these two values are the same, so therefore we will get cos phi minus alpha plus beta equal to cos phi minus alpha minus beta. So ഈ രണ്ട് ടേംസും ഈക്വൽ ആയിരിക്കും. So we will have this equation. Now if you have cos A equal to cos B, then we will get A equal to plus or minus B, because cos of minus B that is same as cos of B. So here we will have phi minus alpha plus beta, that will be equal to plus or minus phi minus alpha minus beta. Now again here, if phi minus alpha minus beta is equal to phi minus alpha plus beta, so in this case ഇത് രണ്ടും cancel out, so we will get 2 beta equal to 0, so that means beta is equal to 0 here. പക്ഷെ beta cannot be 0. In that case, if beta is 0, both the vectorial axes will be same, which is not possible. So therefore beta cannot be 0. So here the sign cannot be positive, so here you must have phi minus alpha plus beta equal to minus of phi minus alpha minus beta. Now from that condition we will get phi minus alpha plus beta equal to minus phi plus alpha plus beta varum. So beta will cancel out, so we are going to get 2 phi equal to 2 alpha, so which will give phi equal to alpha. So from this equation namukku phi equal to alpha kittum. And now substitute phi equal to alpha into this equation. For phi equal to alpha substitute ചെയ്യുമ്പോൾ here you will get cos beta, here cos of minus beta, which is equal to cos beta. So the equation will reduce to, so we will get a single equation. So L by rho will be equal to minus e cos phi plus cos beta. From this we will get L by rho equal to plus e cos phi equal to cos beta. Now in the equation 1 we have sec beta, L by r1 plus e cos theta 1 എന്ന് പറയുന്നത് sec beta into cos theta 1 minus alpha varum. So we have got an expression for cos beta, so substitute for sec beta here. Okay, so cos beta is L by rho plus e cos phi. So from equation 1 we will get L by r1 plus e cos phi 1 into 1 by sec beta varum. 1 by sec beta is cos beta, that will be equal to cos theta 1 minus alpha. We substitute here for cos beta, so cos beta is L by rho plus e cos phi. So this will be the required equation. So this is an equation involving r1 theta 1, which is the pole, and the coordinate rho phi, whose locus will be the polar. So therefore the locus of rho phi will be equal to, now let us replace rho and phi by r and theta. So we will get L by r plus e cos theta into L by r1 plus e cos theta 1 equal to cos theta minus theta 1. So this is the equation of the polar of the pole r1 theta 1. Now as you can see, this equation, the equation which we have got here, is same as the equation of the chord of contact. So the polar of a point with respect to the conic coincides with the chord of contact of tangents from that point to the conic, then the point is outside the so then the point is outside the conic. So in that case, the equation of the polar will coincide with the equation of the chord of